if your parent is not null and you are also a parent of someone else, that means you are a. Hey guys, welcome back to our channel. This channel, where science is all about trying to learn various concepts of data science by practicing a lot of questions. In this video, we are going to solve this question on Leetcode regarding binary tree nodes. The difficulty level of this question is medium, and I'm going to share the SQL schema as well as the Pandas schema in the description box below. Okay, the question reads, we are given a table called tree with two different columns, n and p. N is the column of unique values for this table. Each row includes n and p, where n represents the value of a node in binary tree and p is the parent of n. Okay, we are asked to write a solution to find the node type of binary tree. Output one of the following for each node. Root if the node is the root node, leaf if the node is the leaf node, inner if the node is neither root nor leaf node. Return the result table ordered by node value in ascending order. Okay, let's go through this example. So here we have various nodes and their parents. So basically, if you are a root node, that means you are the ultimate parent. So there is no parent that you have, but you are the ultimate parent. So if you look at this, right, node equal to 5, there is no parent for 5. So 5 is a root node. Now you are a inner node if you have a parent and you are also a parent of someone. So let me just switch to this thing. So this is not exactly the same as the example, but I just want to explain you like what basically all these three different categories mean. Is that okay? So this is the root node because you are the parent of people, but you don't yourself have a parent, right? Secondly, this is an inner node because 7 has a parent too and is also a parent of 2, 10 and 6. These kind of stuff, right? 2, 10, 5, they have a parent, but they themselves are not a parent of someone else, right? So these are leaf nodes. So to solve this question, what we need to do is we can apply the same logic, and based on that you have that okay, 5 is the root node, 2 is inner, and so on. So let's apply the same logic here. So from this table called tree, we need in our output the n column, right? So return me n, and then let's use a case when statements because we need three conditions that needs to be checked. Firstly, if p is null, that is you do not have any parent, that means you have the root node. So case when p is null, then it is a root node. Then when p is not null, and you need to make sure that you are also a parent of someone else. So what you do is and n in, and let us return distinct parents from the table called tree. So that is going to give us okay, if you are also a parent of someone, right? Again, switching back to this, if your parent is not null and you are also a parent of someone else, that means you are a inner node. So then you are a inner node. Else the only condition that is remaining is that you are either going to be the root, inner, or leaf node. So you can just simply write else you are a leaf node. Since you started a case when statement, you need to end as what is required in our output type. So alias this as type, and you should also order this by node value in ascending order. So order by n in ascending order. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is exactly same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. So not a difficult question if you know the concept of root, leaf, and inner node. Just to summarize, if you are the only parent and you do not have a parent, then you are the root node. If you have a parent and you are also a parent of other nodes, then you are an inner node. And if you only have a parent but you are not a parent of someone else, then you are a leaf node. And that is the same logic that we applied here. So yeah, this is how we do it. Let me know if there is a better, more efficient solution to solve this question. Let the solution be in the comment section below, and I'll see you guys in the next video.